everyone. Myself, Anjana K, Assistant Professor, Department of CSE, Vedavyasa Institute of Technology, and I'm here on topic unit and its variants for medical image segmentation. And for an overview, here we have introduction, why unit architecture, unit variants, image modalities, applications, unit in COVID-19, and finally the conclusion. Here, unit is an image segmentation technique developed primarily for image segmentation tasks. These traits provide unit with a high utility within the medical imaging community and have resulted in extensive adoption of unit as the primary tool for segmentation tasks in medical imaging. The success of unit is evident in its widespread use in early all major image modalities from CT scans and MRI to X-rays and microscopy. Furthermore, while unit is a largely a segmentation tool, there have been instances of the use of unit in other applications. So here is the CNN, the network which is mainly used for the image processing technique. This gives the more clarified image and also to rectify each and every object in the given image more clearly. The CNN algorithm is used and the given architecture is provided here. Here there are certain layers are the convolution layer, max pooling layer, convolution 2, kernel, varied padding layer, and the fully connected, fully neural connected, and RELU activation layers. And here it is the distribution of unit related papers in the given survey by the year of publication, and also here is the another image is used for the image modality in unit related papers, and also the application area in unit related papers. It should be noted that some papers had multiple image modalities and application areas, and each instances was counted separately. So why unit? Unit is a neural network architecture designed primarily for image segmentation, and also it is the basic structure of a unit architecture consists of two parts. And the first path is the conducting path, also known as the encoder or the analysis path, which is similar to a regular convolution network and provides classification information. The second is an expansion path, also known as the decoder of the synthesis path, consisting of up convolution and concatenation with the features from the contracting path. And unit is particularly useful is its creation of highly detailed segmentation maps using highly limited training samples, and the challenge to separate stretching objects of the same class, which is being resolved by applying a weight loss function that penalizes the model if it fails to separate the two objects. And the unit is also much faster to train the most other segmentation models due to its context-based learning. Next, let's check out the unit architecture. As we discussed, expansion path, and the second one is the expansion path is an expansion consisting of convolutions and concatenations with the features from the contracting path. This expansion allows the network to learn localized classification information. Additionally, the expansion path also increases the resolution of the output, which can then pass to final convolution layer to create a fully segmented image. The resulting network is almost symmetrical, giving it a U-like shape. The unit network was developed based on the works of Log using fully convolution networks. Their implementation achieved better performance than previous best on the ISBI 2012 challenge and won the ISBI cell tracking challenge. And here is the unit architecture. Here we can see the 3x3 convolution RELU layer, 1x1 convolution, crop and concatenation, 2x2 max pooling, and 2x2 convolution. And the arrows represent here in the picture, the arrow represent the different operations, and the blue boxes represents the feature map at each layer, and the gray boxes represent the cropped feature maps from the contracting path. Next, the unit architecture. The architecture shows that an input image is passed through the model and then it is followed by a couple of convolution layers with the RELU activation function. And a reduction in all dimensionality happens. Apart from the convolution blocks, we also notice that we have an encoder block on the left side followed by the decoder block on the right side. And the encoder block has a constant reduction of image size with the help of the max pooling layers of strides too. And once we reach the decoder aspect, we notice the number of filters in the convolution layers that starts to decrease along with a gradual upsampling in the following layers all the way to the top. Now let's check the unit variants. There are base hue unit, 3D unit, attention unit, inception unit, residual unit, recurrent unit, and dense unit. First of all, the base unit. The unit network can be divided into two parts. The first is the contracting part that uses a typical CNN architecture, that is as mentioned earlier. Each block in the contracting path consists of two successive 3 by 3 convolutions followed by a RELU activation unit and a max pooling layer. This arrangement is repeated several times, and also the novelty of unit comes in the second part called the expansive part, in which stage upsamples the feature map using 2 by 2 up convolution. Then the feature map from the corresponding layer in the contracting path is cropped and concatenated onto the upsampled feature map. This is followed by two successive 3 by 3 convolutions RELU activation. At the final stage, an additional 1 by 1 convolution is applied to reduce the feature map to the required number of channels and produce a segmented image. The cropping is necessary since pixel features in the edges have the least amount of contextual information and therefore need to be discarded. This results in a network resembling a U-shape and more importantly propagates contextual information along the network, which allows it to segment objects in an area using context from a larger overlapping area. Next, let's see what is 3D unit. 3D unit is an augmentation of the basic unit framework that enables 3D volumetric segmentation. And also, the core structure still contains a contracting and expansive part. However, all of the 2D operations are replaced with the corresponding 3D operations, namely 3D convolutions, 3D max pooling, and 3D up convolutions, thereby resulting in a three-dimensional segmented image. This network is able to segment images using minimal annotated examples. This is due to 3D images having many repeating structures and shapes, thereby enabling a faster training process even with scarcely labeled data. And the 3D unit has seen extensive use in volumetric CT and MR image segmentation applications, including diagnosis of the cardiac structure, bone structures, vertebral column, brain tumors, liver tumors, lung nodules, nasopharyngeal cancer, multi-organ segmentation, head and neck organ at the risk assessment, and the white matter tract segmentation. 3D unit has been used to great effect in many biomedical applications, which created a network that produced multi-level segmented images that allow abstraction when making a diagnosis. Next, let's check what is the attention unit. It is an often desirable trait in an image processing network is the ability to focus on specific objects that are of importance while ignoring the unnecessary areas. And the attention unit high achieves this by making use of the attention gate. An attention gate is a unit that trims features that are not relevant to the ongoing task. And each layer in the expansive path has an attention gate through which the corresponding features from the contracting path must pass through before the features are concatenated with the upsample features in the expansive path. And the attention unit is useful in encoder-decoder models such as the unit since it can provide localized classification information as opposed to global classification in unit. This allows different parts of the network to focus on segmenting different objects. And next, the residual resid. Next, we look at the residual unit. This variant of unit is based on the ResNet architecture. The motivation behind a ResNet was to overcome the difficulty in training highly deep neural networks, and ResNet lessens this problem by utilizing skip connections which take the feature map from one layer and add it to another layer deeper in the network. And also this behavior allows the network to be better preserve feature maps in deep neural networks and provide improved performance of such deeper networks. In the residual unit at each block in the network, the input to the first convolution layer is added to the output from the second convolution layer using a skip connection. And while checking image modalities. Segmentation is the primary task for unit models. The goal of segmentation task is to outline and separate different objects in an image. That is, to classify different objects rather than classifying the whole image. This is of particular importance in medical imaging community as the diagnosis of medical conditions requires careful analysis of local regions in an image. For instance, the diagnosis of brain tumors would require separating the tumors from the rest of the brain structures. And we have found that the extensive use of the unit architecture for a wide assortment of medical imaging analysis. And also, it is mainly used in some areas such as in the magnetic resonance imaging, that is MRI, computed tomography, CT, retinal fundus imaging, X-ray, ultrasound, and finally the dermoscopy. Next, let's checking the applications of unit in biomedical segmentation, such as brain image segmentation, liver image segmentation, as well as protein binding site prediction. Variations of the unit have also been applied for medical imaging constructions in order to check out the prostate cancer, liver cancer, nasopharyngeal cancer, breast cancer, blood vessels, uterus, vertebral column, and the spinal cord, femur, placenta. In order to identify all such things, the base unit and the different variants of the unit is used. And here are the some unit applications in the it shows some the what corneal and placental and the femur like images are shown here. And unit in COVID-19. The novel coronavirus COVID-19 virus pandemic has created a staggering global medical crisis. As of October 2nd, a total of confirmed cases and confirmed deaths have been recorded globally. To combat this challenge, the medical imaging community has involved itself in the research of multiple deep learning techniques, including UNET, for the diagnosis of COVID-19. The primary diagnostic images taken for COVID-19 are chest CT scans, which are ideal given that UNET has seen extensive exploration in that modality. And the versatility of the unit network has allowed rapid development and deployment of early screening diagnostic algorithms for field use as March 2020. And finally, as the conclusion, unit which is a powerful we aimed to provide a starting point for research to explore UNET, which is a powerful deep learning model used extensively for medical image segmentation. And also to do so, we explored many variants of UNET and its diverse applications on a multitude of image modalities. And also examine the major deep learning methods and their application areas for all of the people, all of the areas, their application areas for all of the in the survey. Indeed, UNET based architecture is quite groundbreaking of and valuable in medical image analysis. The growth of UNET lends credence to its status as a premier deep learning technique in medical image diagnosis. And thus, despite the many challenges remaining, deep learning based image analysis unit will be done of the major paths forward. And thank you.